Alright guys, so we're going to start going over the Arduino code necessary to control our remote control card in the car driving mode. Like before, we're going to have to include the same libraries, wire.h, software serial, and the three libraries necessary to interface with the IMU. We need to declare our constant integers for the RX and TX in order to set up communication with the XB. We also are declaring two different integers now for the maximum displacement values. And we've created two instead of one like last time because we want to specify different maximum displacements for the Y and Z axes. Now this isn't totally necessary, but it allows you to kind of personalize your code, what makes you feel comfortable when you're actually shifting around the controller. So like before, we're going to set up an object called BNO using the IMU. In our void setup function, we're going to start communication with the XB using xb.begin at 9600. And then also like before, if we are not able to start a connection with the IMU, then we'll just go into an infinite while loop and pretty much stop our code. We'll wait 1 second in order to let that setup happen, and then we dive right into our main loop. In our main loop, we are going to get a new sensor event using, as you can see, set up an event and then bno.getEvent. That's going to get all of our new sensor data that we need. Next up, we're going to declare two different variables called ydisp and zdisp. Those stands for the displacement values or deflection values from the zeros on both the Y and Z axes respectively. All it takes to get those is event.orientation.y and event.orientation.z. So those are now stored as doubles. Next up, we're going to declare a variable called zmag, and this is the magnitude of the deflection in the z-axis. So basically that's just what our deflection is over what we said our maximum is. So it's basically a ratio from 0 to 1. In case that ratio is more than 1, we want to make sure that we reset it to 1. So using both a min and max function, we are ensuring that our ratio is between -1 and 1. Let's say if our Y displacement is greater than the maximum displacement that we already set, and our Y displacement is greater than 0, then we're going to reset Y displacement to our max displacement. And the same goes for the negative version for the Y-axis. Last but not least, we're going to print our information to the XB, send it right over to the car using xb.print. And the two pieces of information that we're going to be sending is the magnitude that we defined up here between -1 and 1, and the direction that we want to be traveling. And both of those will have precisions to the 100ths place, so 2 decimal places beyond the period. So now let's go look at the code on the car and see what it looks like. Alright guys, so we're going to start looking at the Arduino code for the car driving mode, and this is the code that's going to go on the remote control car itself. So like the tank driving mode, we're going to include two different libraries. One is for the motor controller, and the other one is just our software serial library that we've been using up till now. Next off, we're going to declare our RX and TX pins, just like before, as constant integers, and use those to set up the XB communication. All of these initializations for these variables, these are variables that we're going to use later on in our code in our main loop, and we'll come back to these once I show you where and how we use them. So like before, we're going to set up an object called MD, and that's going to represent our motor controller. In our setup loop, we're going to begin our communication with the XB with xb.begin, and that's at 9600 for our baud rate. And also we're going to initialize our motor controller using md.init with open brackets. And now we come to our main loop, and this is the loop that's going to be running over and over again. So this chunk of code is exactly the same as before. We're going to check to see if our XB is available, and then if it is, we'll read in the next character. And if it happens to be an end line, then that means that we've reached the end of the most recent command sent by the XB, and so on and so forth. This is the exact same code that we looked at before. To continue, if parse time is true, which means we've received a full command from the XB, we're going to search for the comma in the command that was sent, and that's going to be stored in the variable called comma as an integer. And then we're going to separate that string into a magnitude and an angle. So basically whatever comes before the comma is going to be our magnitude, and whatever comes after it is going to be our angle. And those are both stored as doubles, which we initialized during the loop. Next up, we're going to determine the direction that we're going to be traveling. These variables called max velocity, that represents the magnitude, but in the sense of what speed we're going to set the motor to. So remember that the speed on the motor can be set through the motor controller, and that's from the range from -400 to 400. So we're basically turning the magnitude that we received from the XB and translating that into a number between 0 and 400. And we're taking the absolute value of that because we will deal with certain directions later on in the code. Next off, we're going to set the left and right velocity. That represents the velocity on the left wheel and the velocity of the right wheel. We're going to set both of those to our maximum velocity that we write in this line. It's not going to stay that way. We'll see later on in the code that in order to turn, you have to spin one wheel faster than the other, but we're going to deal with that with these if statements right here. So let's say that the angle that you receive from the XB is smaller than 0. That means that someone turned the controller in a way that made us want to turn right. That means that we want to decrease the velocity of the right wheel so that we turn right. So there's two different ways that you can do that. You can either develop a linear relationship between the magnitude of the speed and the angle that the controller is turned at, or you can use cosine. The linear fit will feel a little bit more natural when you're actually turning the controller with the IMU. It'll seem more like a car. So the way that you do that is you can just basically derive the equation of a linear line. It has a slope and a y-intercept. Basically, your 2 points are 0 degrees corresponds to 1 and 90 degrees corresponds to 0, and anything in between is determined by this linear relationship, which you're using the angle, which is the second argument that you received from the XB. So if your angle is negative, that means we want to go right. If your angle is positive, that means we want to go left, and so on and so forth. The next two if statements deal with the magnitude. If our magnitude is greater than 0, that means that we basically want to go forward. If it's less than 0, that means we basically are trying to go backwards. And so again, like before in the tank driving mode, we have to set these equal to, one of them equal to the positive version of the velocity and one of them equal to the negative version. And that's because in our specific situation, our motors are wired with opposing polarities into the motor controller. Once we've set those speeds using the MD object, md.setMotorSpeed, then we can reset the values that we use to store our strings, like total. And then we're also going to reset our parse time equal to false so that we're ready for the next iteration of reading data from the XB.